Look at the Pont du Gard. These massive stone arches have stood over this river for 2 millennia. The Romans built structures like this to handle extreme weight and outlast empires, all without modern machinery. You can apply that exact same ancient engineering to build a permanent Roman-style stone arch bridge on your own property for under $1,000. But you need to know exactly what you're signing up for. This will take roughly 300 hours of grueling physical labor. You will need friends to help you lift, and you are going to move and shape over 5 tons of raw stone. It is backbreaking work, but when you finish, the result is a permanent piece of legacy architecture designed to outlast modern temporary construction. Step 1 is the geometry. To cross a creek, we use a segmental arch, an arc that spans less than 180 degrees. Wedge-shaped voussoir stones redirect gravity outward and downward, putting every stone into pure compression. Because this weight thrusts outward, the ends will slide apart if not secured. You must dig 18 inches below the stream bed to pour solid concrete footings. These footings follow a strict formula. They must be poured 8 inches thick, reinforced with a grid of half-inch rebar, and they have to extend at least 6 inches wider than the base of the bridge on every side. Digging this deep next to a stream guarantees water will pool in your trenches. You either need to pour these footings during the dry season or temporarily divert the water flow to the opposite bank. Mastering this compression geometry and locking it into an immovable foundation separates a 1,000-year bridge from a pile of collapsed rocks. Now you have to build a temporary wooden mold. This structure will hold the heavy stones in the air until the compression circuit is complete. A common mistake here is trying to eyeball the curve of the arch. To get it perfect, stand a piece of 3/4-inch plywood vertically on the ground and tack a loose string between the 2 top corners. Gravity pulls that hanging string into a perfect catenary curve. Invert that traced curve, and you get an arch handling pure compression. Cut 2 identical plywood pieces. Space them to the bridge width. Connect them with 2x6 boards. Finally, wrap with a plywood veneer. This wooden frame ensures your stone arch precisely mimics the physical laws of compression. It allows the bridge to stand entirely on its own without relying on mortar to glue it together. With the frame in place, it's time to process the stone. Use a rotary hammer drill to bore holes into harvested rock. Insert steel wedges called plug-and feathers and strike them with a heavy hammer to cleanly split the rock. As you cut these wedge-shaped voussoirs, remember one rule. The length and thickness of each stone can vary, but every single stone in the arch ring must be cut to the exact same width. Looking at this arch cross-section, you can see why. Uniform width guarantees an even distribution of surface contact. If one stone is narrower, it creates a pinch point that concentrates pressure and causes severe structural weakness. Lay mortar and place stones up both sides of the frame simultaneously. The final gap requires the keystone. This heaviest piece gets wedged into the top apex to lock the entire structure together. The moment you drop that keystone in, the structure transforms from loose rocks on a wooden ramp into a self-sustaining engine of pure compression. You can pour an optional 4-inch layer of concrete over the hidden top of the arch for rigidity. Then, use a plumb line and mortar to build vertical stone retaining walls directly on top of your footings on both sides. Once those side walls are up, you have a large hollow cavity over the arch. Fill this gap with loose gravel and aggressively pack it down using a power compactor. The compressive force traveling through the stones creates a line of thrust that naturally wants to push the bottom of the arch violently outward. The immense weight of the gravel backfill counteracts this thrust, keeping the system stable. This backfill provides the external pressure necessary to keep the entire bridge from collapsing under its own weight. To finish the walking surface, pour 3 inches of mortar over the compacted gravel. Then, lay natural, flat sandstone pavers across the top, fitting them together like a jigsaw puzzle. Lock the surface together by squeezing a wet grout mix into all the joints, using a heavy-duty masonry bag. Let the entire structure cure. Now you can disassemble the supports and pull that wooden frame out from underneath the span. 5 tons of stone will remain suspended in midair. Grab a chipping hammer, a wire brush, and some muriatic acid to scrub away the excess mortar drips. This process exposes the clean, natural texture of the raw stone. The pure compression locked into the arch allows it to support the weight of a horse, a heavy vehicle, or a large group of people crossing the span without a single stone shifting. Through heavy sweat, basic tools, and ancient geometry, you have turned raw earth into a lasting monument.